Hey, everybody, welcome out to the AI Think Tank podcast. It's our second show. And previously, we've had our guest speaker, Suman Aluru, on before. This is his fourth appearance with us. But for everyone who wasn't a part of our private meetings, we will get you up to speed before moving further downstream with this. Okay. Suman is an outcome-focused technology leader with a wealth of experience in harnessing technology to drive organizational growth. Currently, he holds a senior leadership role at Avantax Wealth Management, where he oversees software engineering and architecture. He is a hands-on technical expert in building generative AI applications and holds certifications in machine learning and deep learning from the University of Texas at Austin, as well as building AI products and services from MIT. Caleb Stevens is an IT infrastructure engineer specializing in developing AI-driven systems that leverage advanced vector databases for semantic data management. He is creating intelligent solutions that enhance user interaction and data retrieval by processing and storing information in ways that mimic human understanding. It's great to have you guys with us. These are two of my fellow cohorts from MIT, and I'm excited to hear what you've got to say today, Suman. So without further ado, let's get going.
Awesome. Hi, everybody. It's great to meet you guys and to share about the RAFT and the RAG, like why do we really need to use the RAFT perspective? I'm going to have a great conversation with Caleb and Daniel, and I'm sure the rest of the individuals. So feel free to have the questions and happy to have the great interactive conversation here. With that, I mean, let's start with some basics of understanding around why RAFT, right? So first, let's start with that why factor, and then we'll develop the conversation into the how RAFT came into the picture, the overall from the large language models perspective. So as most of you are pretty familiar, right? Like, every integration you're doing with the large language models or like, building these applications, you definitely need you have to incorporate some sort of information to really gain your domain specific knowledge or your proprietary data or some other context. You really need it. And so far we've been all like, the using various techniques like fine tuning your base models or techniques like RAG, where you're providing the RAG, as most of you probably familiar, it's the retrieval augmented generation. So you're providing this context part of your query itself, and then you're asking the base LLM to provide the information. So when all these things are there, why did the RAFT came and what is it even RAFT for, right? So RAFT is really retrieval augmented fine tuning, and where they basically addressed some of the fundamental gaps between when we do the fine tuning and then when we are doing the RAG, and we'll develop the conversation here like that. With that, I would like to actually start with, as we said, right, this base understanding. So I'm going to share some slides here to make it a little bit more interactive. And let me share the screen. Some of this probably, like, as we are repeating some of this quite a few times, so it might be repetition, but hopefully it's valuable, as the repetition sometimes make it even more, concrete in terms of our understanding ways. As a lot of you are very, very familiar, like, the whole zero-shot based prompting. What we mean by that is, as a individual user, I can ask a question or a prompt to your base LLM. What are the base LLMs we are talking about? Any LLM today, like, whether the GPT-4, 3.4, or Gemini, or Mistral, or like, Anthropic, whatever the LLM you are really using, you have a specific question and the LLM gives you an answer. Now, how is LLM is giving the answer? As some of you might be already aware, these LLMs really got trained with the corpus of information, what was publicly available or what was available within those forms, right? So the knowledge, what it has is the information, what it is provided point in time. And it's doing a pretty good job with the point in time history of information and giving that. What do we mean by that? Let's take a simple example here, right? So for example, I was asking about, hey, what is the total solar eclipse? Provide me two small paragraphs of that particular solar eclipse, right? Because solar eclipse happens quite often. It's not about the recent solar eclipse, which was, by the way, beautiful. I was in Texas and I saw that solar eclipse. It was beautiful. So
I got to catch it from my backyard. I'm in the DFW area, so yeah, we it was fantastic.
it was beautiful. So that's a good part, right? We'll come to that part of the
Yeah,
thing. When we ask the LLM, what is the total solar eclipse, and it really provides. But if I go ask the same LLM, hey, how was the total solar eclipse happened in the 2 days back? The same base LLM don't have any context because this was built the past history of information, right? That's the fundamental thing. That's the fundamental problem. And also, I gave that similar example. I took our famous Daniel's AI think tank podcast, and I went asked the ChatGPT, hey, provide me, what do you think about AI think tank podcast? It never says no, by the way, right? So that's a problem. That's the problem with some of these things, right? Because if it had any contextual information, it tries to pull some of those things. So sometimes it might be relevant, it might not be relevant, but it is going and pulling and giving very general information about this think tank podcast and this Chatham House and bunch of other things. That was not the intent of my question. So that's a fundamental gap here, right? So the gap here is the information what you train is what it does the job of giving, but the information which is after the training, it's missing.
and we
Of
would
course.
call when it sidesteps like this or provides non-factual information, we would call these hallucinations in the AI, right? Where
Exactly.
it kind of just makes its own data as it goes along.
Exactly. And that's a big problem, especially when you're trying to build these enterprise applications or any business applications. You want to limit that, you want to control that. It's very important one.
Exactly.
How do we,
Yeah.
right? So how do we control? So the whole concept is about the accuracy, as Caleb was mentioning around the hallucination. So how do we really control? And so there are quite a few techniques, and this is one of the technique we are going to develop using the RAFT, and that's what we'll discuss. Now, so the first thing we talked about when we earlier, right? So the base LLMs are there and some of the methods are the fine tuning is one of the method. So let's see it, right? So I actually went and did took a Mistral and I went and fine tuned one of the Mistral. And I said like, I trained it basically taking the data from the AI think tank podcast website. And I trained this model. And now after training, so I took this base model. If you see really the flow here perspective, right? So the base model was exists, whether in this case I took the Mistral, and then I took that base model and I trained it with very simple information, telling about which I extracted from the website, what Daniel has around AI think tank. And I literally put this information there and I trained that and then created the model, right? Now, this fine-tuned model, which is very specific versus the model which previously we taught, right? When I asked this model about, hey, what is AI think tank podcast? It's now giving the relevant information. So that's what the basically it's like. So it's getting my pre-trained model, which is the model which I pre-trained, and looking at it, and it's able to get the answer what I wanted. Okay, this is great. So why do you need anything else? Someone like now, hey, I can go, I can train, I can do it. But it's the same fundamental problem, right? That fundamental problem is time don't stop for anybody. That means the current session, what is happening, how does it know about that information? So again, this means this is the information what is available previously is able to do it, but as the time is moving, you're missing that knowledge, you're missing that intelligence around it, right? So that's where the fundamental gap around, even though it's a fantastic to really train on your private data, if it is a static, if it is not changing, absolutely this model might be the great, but I don't think any business has a static, always there is things change. So you really need to have a context-based awareness, which is a point in time based awareness to really get that information, right? So that's where the RAG concept comes, right? So here we are not providing any context. So part of the retrieval augmentation is how do I provide the context of the continuous, either with the private knowledge base or an active current situation? I can able to provide that context in terms of my question and prompting to the respective LLM, and it should be able to give me an answer. Okay, so let's go through that model around it, right? So I took this one from some of the medium, like, we had these flows. And so what I'm going to go through this high level RAG, this retrieval augmented generation, how the RAG is doing. We'll spend a little bit of time, and Caleb can jump into the vector space perspective. If anybody has any questions, he can go more deeper, and we can able to help you guys understand around it.
Yeah, just raise your hand if you have a question, and we'll bring you up. Okay, no problem.
Awesome. Thank you so much. Yeah. And once we get this RAG common understanding across all, probably some of you are very well aware, but let's develop the content in the way so that we can able to get to the RAFT in a much more detailed perspective. So as every one of us, like, wherever we are working, whether it's our own startup or enterprise or the things, you all have your own private knowledge base. As we were explaining in the previous, you are not able to provide that context of that private knowledge base if that particular knowledge is not there either in the fine-tuned model or your base model. So how do we really augment this information to the LLM so that it can able to provide that information, right? It could be any lot of databases here. I mean, a lot of us has the NoSQLs or the RDBMS or other databases are there, where the structured or unstructured information is there. So how do we really take advantage of that? So what RAG does is, so you will be maintaining a private, basically like, a vector store more into the semantic way, so that when the time of the prompting, you're able to do it. And how it is happening, we'll go through a little bit more detail here. So as a step one, as you're seeing, so you identify your structural internal documents perspective, right? Once you identify your internal documents, as we are showing here, the chunking, literally chunking is nothing but you can think of a partitioning of that information. If it is a PDF, I can break down that PDF into a multiple paragraphs or a half pages, depending on the type of the document you have. If it is a web page, you can go by the element level, you can go by the whatever the contextual information you wanted to really retrieve, right? Similar to the database. So you have to break that chunks into it. And we can come back and ask the question, why do I need to break the chunk? Why can't I give the entire PDF? Right? You can. But what happens when you give entire PDF? For example, if it is a one page PDF, it's easier. How about if it is a 100-page PDF? If it is a 100-page PDF, is the question I'm asking every time, is that answer exists in all the 100 pages, or is the answer exist only in certain pages? If the answer exists only in certain pages, why am I sending all these 100 pages to the LLM, right? As a context, right? If we are sending as a context, it's an expensive call you're making because you're sending so much memory. First of all, a lot of them don't even allow there is a token limit and all. Let's assume you have your own local LLM running and then you want to send all of it. Still, it's an expensive call you're making. And then as earlier Caleb was mentioning, you're increasing the hallucination, it reduces the accuracy, all those specific problems. So it's that instead of you making the LLM to detect, there are other excellent, fantastic techniques available, which you can leverage to limit what chunks or what particular information you should be sending when you ask a question. So that relativity, and we'll talk about that's what this rest of the 2 to 5 it's really developing, right? So hopefully I'm making sense to you guys, like in terms of why you should be breaking, whether it is a PDF or other things, why you want to break the chunks is really to keep it minimal and then make it relevant to your question, that minimal information, so that the LLM can efficiently operate and provide the performance perspective, response perspective, cost perspective, a lot of other aspects of those things, right? With that, now there is a number 2 step. Like now we've broken down the file into the multiple pieces into it. So once we break down those chunks, what are we doing? We really basically saying, hey, I want to go embed this thing. What is this embedding? Right? What is this embedding? I'll keep it simple. There is a word to vec. If you really are interested to read about, I would start with the word to vector. which is basically how do you convert the words into a vector space and all that. It's a great start. I would highly encourage you to read that paper, and then basically you can develop yourself into the embedding model, how the embedding model works, right? The whole bagging technique and all the other options are there within that one. So to keep it simple in the conversation here, so what we're doing here is we are developing this embedding model. Basically, we are leveraging an embedding model to convert the chunks what we created, which is a plain English text or whatever the context you have, into numbers. Why are we doing that into the numbers? Right? The important part when we say converting into the numbers, we're converting into the vector. Okay, so before we get into here, let me spend a little bit of time, and please, Caleb, chime in if you want to add anything, right? So what we're trying to do is, I'll keep it simple 2D vector, which is basically X and Y plane, right? If you have pets like dogs, cats, and other things, and then you have vegetables, fruits of the data set you have, right? So if those are the data set you have, hey, I want to represent that on an XY graph where relationship of the basically what belongs to pets. So when we draw those things, what do we do? Hey, dogs belongs to one place, cats belongs to one place, right? And so you place them in the XY because they all stay together because those are the pets, animals, a lot of other factors into it. You're not going to put dog and apple together, right? When you're plotting that on an XY. So you're going to plot that into the apples as a vegetables or like fruits, sorry, apples as a fruits, vegetables as a vegetables, and but vegetables and fruits might be in a very close proximity relative to the cat or dog, right? Because of the relationship in this one. So that's what it's really doing. So you're plotting your XY in terms of your context perspective, how your chunks related and where in the XY plane it needs to be. Okay, why are we doing all that stuff? That's the important question is, okay, why can't I just keep it as a English text in some database somewhere in the NoSQL or a document model somewhere and then use it for whatever the reason we do that, as earlier we were mentioning, right? We want to minimize the context information we are sending to LLM to operate efficiently, right? So how do we minimize? Doing a plain text comparison is an expensive call when you're going with a huge knowledge base versus, and then also the relative right information is not going to come. But if you plot that on a vector store, basically as a vector database, right, on a plane, when you're asking a question, like for example, hey, what vegetables are in color red? Right? That's a question I'm asking. So then automatically, if the plot is there by the color, by the vegetables, dogs, and thing, and when you are doing that search, that question also gets converted into these numbers, into a vector, right? So that vector is also get plotted into the same vector space. And then it looks at it, okay, this question is talking about the vegetable and color. So if I'm plotting that into the XY graph, it goes somewhere close to the vegetable area. And then you use this very, very famous ANN search, right? Which is approximate nearest neighbor. Depending on that nearest neighbor, if all these are the vegetable, what I'm going to do, I'm going to pick all the data. I might pick all the red apples, tomatoes, and other things, whatever those reds are, right? I might be picking all of that. And then once I pick the data, that becomes my context for my question. So what am I doing? I'm taking all my information, I'm chunking that thing, asking an embedding model to convert that embedding model basically to a vector so that vector basically able to store it into this vector database. So if it is storing in the vector database, when as a user, when I'm asking a question, I have to use the same embedding model. If you use a different embedding model, it gets super challenging. And why? It's an exercise for you because you get the two different sequence of the numbers and all that stuff, right? It depends on the model, how close it is. But it's always preferred to use the similar embedding model.
Got a question here. Here we go.
Yes.
Caleb.
Yeah, so just wanted to touch on that as well because I've experienced this myself. Is you run into like an overfitting of what you're trying to do almost, right? In the AI. And you're adding this whole level of complexity and latency to the operation because the user's trying to get the information. Well, now the information has to go to another AI to get down to the vector data, retrieve that information, provide it to another AI, then provide it back to the user. So you have this latency that gets involved in there, and you can run long queries and end up with a lot of API usage just getting that data back and forth. It's definitely one of the things that I've run into in my integrations trying to bring in RAG.
Absolutely. That's so it's a very good point and very good problem. Actually, a lot of folks are have. I mean, there is a lot of research is also happening. Actually, very recently, there is a new startup called Unstructured.io. Unstructured.io as a optimal method to identify your data object, like in this case, whether it's a PowerPoint, HTML, or a PDF or a database. And then it has the element level extraction. So you're limiting some of that, how you're doing the chunking. So, and then basically like, you can limit the amount of the embedding you're making the call. Now, embedding over an API, embedding if you can afford your own GPUs and the things, and if you are running on your local, then absolutely some of that you can mitigate in terms of running locally and accelerating it. But you're absolutely right, Caleb. Like, it is a challenge in terms of, I mean, that's a challenge everybody's going through. So how do we really efficiently run, and how do we get the compute services required for some of these things? Right.
Right.
It's a great one. Great question. And suggestion too. So the part of this thing is like, so as we are asking the question, as Caleb was mentioning, right? It's not only the one time of your knowledge base setting and putting into it, but it's also your question, right? The bigger the question it is, or the bigger the context you're providing in that question or the query is also needs to be converted into the vector, right? So for example, if I write, you will see this, and I'm pretty sure you might have come across this quite a bit, right? So if I give a huge question, like when I say huge question, like, my question is like a, let's say 10-line question with a lot of information in it, right? So then sometimes your relevant answer might not be as accurate as you want it, depending on the type of the question you're asking, because the embedding, what it is doing, and then the retrieval of that information could be massive. When I say massive, it might be pulling almost a lot of chunks, right? That's one of the biggest problem. If it is pulling a lot of those chunks, how does the LLM know what chunks really are good for the answer, what chunks are not good for the answer? It becomes challenging because you are telling the LLM that this is the context I want you to use. This is the latest information I want to use, right? So it's going to use all of it. And depending on the information, how it is laid out, how the context is maintained, the attention is maintained, you might get the more answer than you wanted, which might not be relevant, and then your accuracy rate goes down. So that's the biggest challenge in one of those.
And we
So
call that noise, right? When
yes,
it's retrieving incorrect information, or that circle grows larger around other items, we call that bringing in noise as it runs the query.
exactly. Very good point, right? So for example, if we expand this circle to this, so now you're picking up all these chunks which are might not be relevant to your question. And then because it's there in the context, you're getting unnecessary answer, and then it's making more complex, right? So that's what happens here. So when you're querying, it's pulling all this information, making as a prompt. I'm pretty sure you all are hearing about the prompt engineering, prompt templates, a lot of that stuff, and which is also getting innovated very aggressively as we speak with DSPy and a bunch of other things. But as the context is going, you're formatting that into the right prompt with the query, which is the question you're asking. Hey, here is the additional context. You're going, asking for the LLM, and LLM is providing the answer, right? Fantastic, great, it's done. Then what problem are we trying to solve now? Hey, you said the base LLM, we started it because base LLM did not have the context it's required. That's where you said, okay, hey, why don't you go with the knowledge base of your private, do the fine tuning. You're able to get the answers, right? With the fine tuning. Then we identified the problem that, okay, it's great. It only the knowledge base of the past, but not the current information, it's not able to take it. That's where you said, like, we started with a RAG. So now with the RAG, you're able to provide the context. You're getting the answer. Aren't you satisfied already? Why are you need another one? Right? That's the question. Why do we need another one to go really look at? The challenge, what's happening with the RAG, as Caleb rightly mentioned here, right? We need RAG, and RAG does address a fantastic, phenomenally lot of this private knowledge-based perspective, and actually it's reducing quite a bit of a cost overloading onto the LLM, and a lot of great stuff it is doing. But it's also getting critical to retrieval perspective of the information, what you are retrieving, right? So you're retrieving this additional information. When you're retrieving additional information and sending it to the prompt, it's LLM is taking everything as a good context. Because as a user, we are sending, this is all good stuff I am sending to you. Consider everything is good. Right? Because we don't know what is good, what is bad. What I mean by that good and bad is, what's a good document here? What is a distractor here? This is a distraction. This is a distraction if your query perspective, right? So if it is coming, it's a distraction. But LLM don't know that. Sometimes it knows, sometimes it don't know, because depending on the chunk has. So it's a distraction. When you have a distraction, what happens in the LLM? Hallucination, wrong answer, quality goes down, more compute power, lot of other side effects. That's the biggest challenge and especially as this knowledge base growing and growing and growing, you'll have a more bigger and bigger the problems are, right? So that's where RAFT is one of the technique. There are a lot of other techniques available on top of RAG. Like, some of them are basically you using the knowledge graph as a separate metadata, augmenting the RAG to minimize some of those chunks and other things, right? And there are a lot of great techniques. As I said, like, just recently that unstructured.io, in terms of efficiently identifying the document, efficiently identifying. What I mean by that, efficiently identifying the document. If you have, let's say, HTML is a nicely, beautifully structured document, right? As an element, each element has a meaning to it, whether it's a header versus a paragraph versus a thing, right? So it's a very beautifully constructed HTML. So you can take that and you can actually convert that into a JSON format. And then you can take the JSON and really add a lot more additional metadata using the MD model, put it into a vector store, and then all of a sudden your search with this element level metadata rather than just the document level. Now you have element level metadata saying, oh, this is a paragraph. This is a paragraph in the page 1, page 2, page 3, or this is a paragraph in a table, or this is HTML table, right? So you have a lot more intelligence added to those techniques, right? So that's one example. Same thing with the PPT. PPT is a structured document. You can use it. You can extract those PPT perspective similar to the PDF. Now, PDF gets challenging. PDF is the simplest one, but it is the extremely complex problem because you can create a PDF over an image. Can I have a table? I can take a picture, make a PDF, boom, done. Your structure is gone. Your metadata is gone. Everything is gone, right? So then there are a lot of other techniques available in terms of visually inspecting, getting those things. Like visual transformers, are there a bunch of visual transformers. You can use it to really convert those things, right? And convert the data out of it, or a lot of other good techniques are available within that document. So for that to be identified, so you have a PDF, and then within the PDF, you want to identify what are the elements you have, and then what type of element, depending on that, what type of element. What I mean by that is, in the PDF, you can have a table, you can have a plain paragraph context, you can have an image, right? Identifying those elements and then using the right transformer to convert that, take that JSON, put that into your vector. Why you're doing so much ahead of it? Because it's a one-time task to do it. Even if it is an expensive call to go use a transformer, but it is still worth, because you're preparing a knowledge base in a vector store to do that semantic search. So when you do that semantic search using all these basically additional metadata, not only at a document level, but at element level, you're minimizing what type of chunks you're retrieving, like even by date and all other good stuff, right? So it will really help. Now, I know we went down into the different aspects of the opportunities within the RAG. The whole idea, what I'm trying to tell is the RAG is one great concept, but there are a lot of optimization techniques you have to implement on top of RAG, whether it's a retrieval, whether it's embedding, whether it's a vector index optimization. And now we talk about the RAFT. RAFT is more on the area of this. How do we really fine tune this to be very efficient for my RAG? All right. That's why we call it as a RAFT, which is a retrieval augmented fine tuning. So you want to fine tune your model to be optimized for this retrieval augmentation. Any questions, anything before, like anything we are seeing, Daniel, like, we can continue?
If anybody has any questions, raise your hand to talk and I'll bring you up.
Awesome. Okay, while others are looking and thinking about that one, so let me bring the.
Hang on one second. We've got Yemi here. Let me get him up. Here we go. Yemi, how's it going? Great to see you.
Very well, thank you. Well done, guys. This is great.
Yeah.
Thank you.
If you go back to that diagram where it's 4, step 4 in that diagram, you were showing us the RAG diagram, which is very cool. I like it. Where is 4? Step 4.
Oh, save text representation. Sorry, this is the 3, this is the 4. I need to fix that one.
That's what I thought. Thank you very much.
Yep. Thank you for identifying. Now we need to fix that. Yep.
Thank you.
Okay.
So the second question is this. So I can see the use case for RAG, but I'm wondering, by going to, that step 9, where you're still going to the external AI, is that not introducing another kind of angle to the whole equation? Why not stick with, why do you need to go external to the LLM?
Good question. Right? Very good question. Okay. So let's go through the flow a little bit, right? So when you ask this question here, what is it doing? It's going to the vector. It's doing a semantic search. So let's go back to that example of vegetable. Hey, I want to understand vegetables with a red color. So when you say vegetable with a red color, it pulls a lot of them, which are close by proximity without understanding, right? So I could have a red apple here. I could have a red some other thing, whatever it is, right? Like, and then you have tomatoes, you have green tomatoes, other things, etc., etc. So the family is close by. Okay, in the vector perspectives, because you're doing a approximate nearest neighbor. This is not an accurate, it's an approximate. So it's like, so it's a k-mean, right? K-mean cluster perspective. So whatever the clusters are there, you're pulling those things and then have that, it's unformatted information. What I mean by the unformatted information is because when you are taking a document, you're chunking, that's what these chunks are. So this is not a formatted information. So when you look at that information, it's like everywhere, like, it's not a sequential, it's not properly organized. It don't have the right context into it. So if you give it to the prompt saying, hey, this is a question, and here is the rough answer of the information exists in this context. I don't know where, but it exists in this thing. I want you to take it, now use your knowledge of attention to details, understand this thing, and generate a right answer for me. And so for that generation of understanding the context and providing the answer is absolutely required by the LLM. Otherwise, you'll get the semantic search, and sometimes it might be relevant, sometimes it might not be relevant, sometimes it might not be in the human readable format of a properly structured. Am I making sense? So for example, what is the best example of using only this part of the information? Today, when you do a Google search, what happens? When you do a Google search, you get a bunch of links. That's what they're pretty much doing. They're doing a semantic search and providing you a bunch of answers there. But does it have a, when I say today, without the Gemini LLM integration of the old Google, okay? So when we do the search, we get the answers in some sequential order they printed. But There is no contextually explaining, hey, Suman, this is the question you asked. Here is the answer. Here is the absolutely right answer in this particular page. Here is a link. You should go, blah, blah, blah. It don't tell about that one, right? It just gives you a bunch of links. Versus now, if you use the Gemini with a Google search, it's actually giving you a more structured answer, even though the links are there, but it's actually making the answer to very personalized, very relative to the whatever the chunks it is putting. Did I answer your question, Yami?
Absolutely. Thank you very much. Thank you.
And I think to cover there as well is some embedding models you can use to answer questions directly. So you don't necessarily have to go out to an LLM. The reason you would is when you need just more than a question answered, right? If you need it to take the data and do something else besides answer the question, like maybe use that data in answering or solving a problem, that's when you would want to take it out to a larger model that can handle multiple of those tasks.
And we got another question here. Satyan, how you doing? Good to see you. Welcome.
Hey, hi, Dan. How are you? Yeah, so basically, Suman, this is all going great. But I had like a couple of weeks back tried something with GPT-4 All, and I was getting a bit stumped. So basically, what I was trying to do is trying to feed it similar documents. Like just use three, say, washing machine documents, like, so if you take wash three different models, right? And and kind of load them, right? To that. And I was using Mini or Mini LM for embedding and Mistral for the LLM. And I was trying to kind of, see if it can give me some troubleshooting, kind of help me with troubleshooting, right?
Correct.
But it was not able to kind of probably, kind of put the context for those three different kind of models in three different kind of, buckets or for some reason. And it was trying to give always the same sort of answer, not depending on the, the model, basically.
Correct. So you're using the sentence transformer, right? So for the all being one of those, right? So
yeah.
Absolutely, right? So I understand your problem, what's happening, and it's a very, very, very common when you are starting with it, right? So what's happening is, because even I went through, that's why I'm so familiar when you say that, right? So when the initial examples, when I was trying, pretty much, I think most of us go through the similar journey, right? So what's happening in that particular area is you're actually chunking those documents, right? So when you're chunking, that's exactly where previously going back to Yami's answer also, when you're chunking, what's happening is, if you really look at this in the multi-dimension view perspective, right? Those vectors, how you are placing, because it's a similar version, it's a similar data, they're all going to be stay close to in the vector space perspective in a multi-dimension, right? So they're all going to be in the same space. So when you go and ask a query, it says, oh, all these chunks seems to be relative to this thing. Right?
Exactly.
So if you go actually troubleshoot part of your extraction mechanism, and if you print it out, right, those chunks, you literally see it. It's like it's printing all those chunks. It's pulling from your vector index perspective. Between this, if you do a printout on this step, okay, like you do the print, you will see all the chunks it's printing. Oh, sorry, pulling from the vector search perspective, all the nearest neighbor. So that is a problem. That the problem is because everything is staying close by and doing. So there are a lot of techniques. I'll share some. I'm sure Caleb, you can also jump in and share few, right? That's where the metadata becomes very, very, very important, right? That's one of the technique. And there are a lot of other knowledge graphs you can maintain outside and do it, but I'll give you a very simple techniques, right? The simple techniques perspective, you can maintain the metadata, right? Additional about the document, right? And like, as I was saying, I don't know what type of document you have, like if it is a fully text-based without the images, without the lot of tables or the things, then absolutely you can use any technique to really pulling the element level information from that one. What I mean by the element level is that what is the paragraph, what is the header, what is the title, and then you can have those element level also part of the vector store as a metadata. So you have your document metadata and then the element metadata to really chunk those things and then place it. At that time, the nearest neighbor will be much more smarter with relative to your specific question. There is a great deep learning short course is there. If you have patience and trying to learn on the unstructured.io, and that actually helps you quite a bit on how do we address, especially around the chunking and then the retrieval tactics.
Okay. Would graph database or something like that be a bit more helpful?
Absolutely, absolutely. Now, nothing is easy food, right? Because you have to, first of all, before you get to the graph database, if it is a unstructured data, right? Going back to if it is a PDF and PDF has a multiple information in it. So identifying that, extracting that information becomes your critical point, right? Once you understand that critical point, absolutely. Answer is yes, you can use a GraphDB, any GraphDB Neo or like any other one, you can absolutely take advantage. Matter of fact, if you can able to get that extraction, you can use your Chrome or your own vector itself. You can place them. You don't need an additional GraphDB on top. But yes, you can.
Cool. Thank you.
Great. All right. Moving on.
Awesome. Thank you. All right. So with that, I want to really go over the paper around really the RAFT. Hopefully, we were able to develop why the RAFT, right? Just I want to reiterate why the RAFT perspective. The RAFT, which is the retrieval augmented fine tuning, is as we developed ourselves, right? Like when you use a base model, you're only getting the answer with what you know. And then we went with the option of fine tuning with your own private data or the knowledge what you have. But the challenge with that particular fine tuning is you're not able to use the latest information because every time you have to go retune it, and then retuning is pretty expensive. It's matter of fact, it's pretty expensive. And then also it's very challenging also because if you wrongly tune, then the core, basically all those hyperparameters, if you wrongly tune, what happens is the core value of the primary model will be distracted, and then you have a bigger problem with that model, right? So it's very, very important. It's an art. It's not easy. I mean, it's easy to fine tune, but you need to understand that a lot more, right? So that's one of the things. It gets super complex with those things, but nowadays it became super easy with a lot of AI model studios, whether it's a Google Model Studio or Azure Model Studio, you should be able to do fine tuning pretty easily. So that's a part, but the challenge with the fine tuning from there onwards is like, how do we really augment the latest information, right? So that challenge is still there. Then we said, instead of the fine tuning, let's use the technique of the RAG with the base model itself, right? So if I go with the base model with the RAG, absolutely answers a lot of great information, and I'm able to provide the context. But part of the context to providing, the bigger the context I am providing, the bigger the distraction it is creating. What I mean by that distraction, as I said, right, in that circle, as we saw, like if I go and pick those blue dots in that circle, that mean basically I'm giving the extra context which is not needed for that question and answer, which is a distraction, and then distraction causes the LLM to hallucinate and not meet the accuracy what you wanted, all other problems, all right? And so that's the reason. So how do we really optimize the model to take advantage of the retrieval augmentation, but at the same time understand the retrieval augmentation concept aspect of it, right? That's what this paper really talks about, right? It's like, the key part it says here, right? How to adapt to pre-trained LLMs for retrieval augmented generated specialized domains. And what that means is, hopefully now you're understanding, right? So the understanding perspective, I have this private knowledge base, I'm doing the retrieval, and I'm retrieving these chunks. And when it's giving the LLM is not able to smartly understand what chunks belong to a good stuff, what chunks belong to a distraction. What I mean by good and distraction, if you go back to that circle of examples with the dots, right? Those blue ones are the distractions. So you will send it irrespective of it. When you do a semantic search, you can't avoid that totally. You can optimize it with the various techniques, you can optimize it, but still it's not avoidable. So while we optimize it, when you do the semantic search, it's always possible that you will give a distracted, meaning the other chunks which are part of that search, right? So how do we make the model intelligent enough to understand that when I'm getting this thing, what is good, what is bad? That's what the RAFT is about. And what we will see is we'll see how they did it, higher level, and then what are the metrics it really provided. I'm really excited. I'm actually playing quite a bit around this thing on my personal basis. So that's what I'm really fascinated about this thing. I think if we can really optimize the retrieval tactics, embedding tactics, and the vector optimization with a lot of metadata externalization, and then as soon as we optimize that whole retrieval augmenting perspective, and then having a solution like RAFT, I think it will solve a lot of problems, especially for the business applications where it is very private domain specific one, where they wanted to protect within the on-prem. All right, with that, the way they did this experiment really, or the model, they came back with pretty much a model learning some subject and writing an exam. Okay, that's what they did. How do we really make a model to learn a subject and basically, so that's what they speak about here, somewhere, private domain knowledge base. But to keep it simple, right? So in this one, is it visible for you all? I'm just going to make it a little bit more. Okay. So how best to prepare for an exam? Okay. These are all the different sections. They don't talk quite a bit about the domain specific, but which is the fine tuning. We'll focus on this here from step one. This is what we talked about, the closed book, meaning you have your base model, which is what we were talking about, which was built with some previous knowledge and whatever it is there, right? We looked at it. For example, when I asked for the solar eclipse on that query, it went to the base model, it generated the answer, gave you the answer. It's right or wrong, it gave you the answer, right? Very confidently. So it will give you the answer, you get it, but it's a closed book. Now, when you ask, hey, solar eclipse on the X date, how was it? It don't know because it happened just a few days back. It don't have that information here, right? So that's why the closed book will not able to answer those type of questions. It failed. For that, what they did, okay, hey, so we have a closed, basically like this base model is there. How do I augment, which is a retrieval augmented model here in this case? So why don't I provide some additional context, additional information here? That retrieval aspects of it, right? So this is the open book. That means I have a vector database somewhere, and when I query, it goes to that vector database, pulls some of those chunks and gives it to the model, the robot, and oh, it says, okay, now I understand the question. Oh, you expressed how it was, just like Caleb and myself, we both, let's assume we both wrote a reviews on the solar eclipse. We felt great, from our backyards, enjoying this view, beautiful life in, once in a lifetime, we could able to see it, all that great stuff, right? Now the model understands that context. It says, yep, Suman and Caleb watched it, did a great job. They enjoyed it. They thoroughly spent time on a backyard and a patio, whatever the information we are giving, it gives you the answer, right? That context is aware. Whereas that context was not aware here, that context is aware here because we are providing. Now, unfortunately, if Suman and Kilab also having that evening, having a great time with a great temperature, having a great beer or other barbecue, other stuff, if it is there in that context, what it does, when you ask that question, solar eclipse, okay, because it happened on the day, it also pulls it. Oh, he had the beer, he had the barbecue and all that information. That's the additional distraction here, right? Even though it's giving the answer, but if I had those parts in that vector database where we were having a great time on the backyard, and if we had that information also part of it, unfortunately, the model thinks it's related to that, and then it answers them, which is a distraction, which is not really required, right? Sometimes it avoids depending on how you're laying out, but you can easily confuse, right? Hey, this is on the same solar eclipse day, I'm having a beer on the back. Now you're in your statement, you're saying solar eclipse, and because it says solar eclipse, automatically it indexes you on the that particular, that multi-dimension perspective. When you vectorize, it puts you into that chunk. Because you have a solar eclipse there, then automatically it will pull. But it's a solar eclipse day. We are asking experience, but we didn't ask it what he is doing, right? So there is a difference there, right? So that's what I don't understand, right? It's a distraction. So how do we train the model to understand that more intelligently? That's where the RAFT they proposed. They said, hey, it is possible when I go to the vector database, when I ask a question, I get some good information which is relevant to that question, but I also get some other information which might not be directly related to it. So how do the model really need to understand is, why don't you train the model in that context, right? Like, if it is a private knowledge base, right? We're talking about the private knowledge bases here, right? Where especially for the RAGs. So if it is the case, why don't you update the model saying, hey, this is my domain, and these are the type of documents I do, and this is how my chunks, my stuff is there. So why don't you let you know, a model, why don't you let you know that this is how I'm giving you the chunks, this is how I'm looking for the answer. That's exactly what they did. They did was, they looked at these things, they vectorized, they trained the model, how those documents are extracted and how the distracted information and good information was there, and then updated the model. Once you update the model, when you ask any other question, right, it knows what's the good document versus what's the distraction. And on top of it, the performance was tremendously improved because it understands that context way ahead. And we'll see it, some of those comparisons. Any questions before we go further, or Caleb, or you want to add anything specific? All right.
Here we go.
Hey, Suman, so if we give some private information to the model and train the model, then is it going to go out in the world, or will it still be private?
Okay.
Because we have now trained the model, right? So
Yeah. So two questions in that one, right? Like, let's make sure our assumptions are correct into it. First of all, 90% of the time, no model can be taken out and run out into the other places, right? So there is a concept like online learning. I don't think any models are there today which are online learning enabled. What I mean by that is, they're not learning on demand with the information what you are providing and updating the model right there. There's no model. I mean, it can, right? That's what they do internally. But whether it's a GPT-4 or Gemini, any of those, there are no online learning models. So let's take that out, right? But if you're using Gemini to do some other stuff, so the companies are already very explicitly saying, right, whether we use this data or we don't use this data. So if your problem, what you're saying, Satyen, so let's say I'm assuming it, right? So you're not using GPT-4 or you're not using any of that. Or if you're using GPT-4 and Azure as a private, then it is absolutely your own private data set. That model is not going anywhere else. And most of you probably very, very familiar, right? All these models pretty much runs on a container.
yeah.
Attach it to a GPU. Okay. So it's a very, very specific. It's like, it's a simple file which has it, and it's attached to a GPU. And so it's very proprietary to you, given whoever the vendor is doing. So, right, you need to make sure. Now, Suman, I'm not talking about the public LLM models or public information. I'm talking about the private. I am running my own Llama 2, my own Mistral on my own infrastructure, right? With the GPU allocated XYZ, then absolutely your model, what you're tuning, what you're giving, you're isolating it to yourself, and that model will never go anywhere other than in your own premises.
Okay. So because Caleb is there and he's from infrastructure, he probably know the answer to my other question, then the follow-up one. So if we do like train the model on Amazon AWS Bedrock, then will it still be private? Or because that, I think, again, as Suman said, it's in a container, right? So that container is not going anywhere. I can kill it and it's all gone. All the information is gone, I suppose, or I'm assuming here, actually.
So my understanding of how those work is it's really all down to the terms of service, right? When you're using OpenAI, when you're using AWS or meta embedding models, if you're running it in their cloud or on their platform, then if they will have some type of access to that data. As far as I know on OpenAI, they do not use your API or fine-tune models to train their own models. That's in their terms of service, but I would look very closely at what AWS has written there. If they are keeping copies, or if they do pull some type of semantic search from your data to help train their models or improve their embeddings. But I would look very closely at those.
Okay, thank you.
Yeah, and
Thanks,
also
man. Thanks, Caleb.
just to add what Caleb said, right? It's very, very important. I think the agreements are very important, and especially if it is an enterprise. So for example, if it is Azure Enterprise using the OpenAI, they absolutely provide private. They provide private.
Yep.
You have to make sure you get that. It's part of it. Same thing with the Vertex, which is the Google Vertex, right? So Google Vertex in the enterprise, it does. But if you go use the Gemini API, and a thing. So there are cases where if the response is not there, they basically they very clearly, explicitly in their disclaimer, they say it, right? If there is the thing, we going to use your information. So don't put any of your private PII or any of personal information part of this thing, right? So the disclaimers are there. So just you have to be watchful of those to make sure what type of model you are using and which type of enterprise service you are using.
Yes, I think so. The key is basically review all the licenses properly, review all the fine text, and then make the decision. And also be on the side of caution, basically.
Always, right? I mean, this is a brand new
Yeah,
tech.
yeah.
You should always, I mean, especially, I'm pretty sure, like, any organization, the very first thing they are going to start with the AI governance than the AI implementation. You need to really have your lines clearly identified, not only just this one, even if AI goes rogue or the model don't give you the performance you wanted, where you're placing, what type of information, what type of impact, and all that good stuff is very, very important. Maybe Daniel, that's one of the days, like, to really talk about the governance, and I think might be a great topic for a lot of folks, because that's the very, very early for any enterprise, matter of fact.
That's right. That's right. Caleb, what you got there?
Yeah, so my question around RAFT is, as the data expands, as you get more of those chunks of data in there, how does RAFT handle that evolving database? How does it go back and maybe fine tune again as you go through there, as those documents expand, as your data grows larger?
Fantastic. I was expecting somebody's going to ask that question, because, hey, how is this different from the traditional fine tuning to this one? So the advantage this thing is because the model itself understood the intricacies of your domain specific RAG here, right? So what we are doing here, we're doing the RAG domain specific until and unless like dramatically change your structure of domain language. You don't need to be really retuned so often, right? So again, it's evolving. You have to really experiment with your specific, but definitely you don't have to do as often as you have to do for the plain fine tuning wise. Here, because you're training how my document structures within my domain, and then the language is there. So it's pretty optimal in terms of identifying what's a distraction versus what's a good one, right? So now, what does that mean, right? So for example, if let's say you are in the business of manufacturing, right? And your RAG is about the manufacturing documents, you're really optimally created your vector store and did all that, and you trained it very well, your RAFT. On that same RAFT pipeline, now you bring back medical surgery information or medical other information, and you expect the RAFT to perform better. Yeah, of course, it's not going to do that. You get my point, what I'm saying?
Yeah, absolutely.
So then you have to, because you're dramatically changed. Now, if it is a manufacturing policy change, a compliance change, or some other thing, I think it shouldn't be that different. That's what it is now. It's an experimentation. You have to do it with your domain specific, and like how dramatic that change, the context changed. The whole idea is you don't have to change if it is a domain that much, but it's a good idea. Just like any other policies, any other things, you can train it. And then the good part, what's the advantage here? Because the accuracy information is there, you're generating the training data set, you already have the previous RAG. So if you go and update the model, reiteration of that pipeline in terms of the validation and the things becomes much more efficient. And lot of platforms like Galileo and there are some great RAG platforms where they actually help you in terms of the training and observability, accuracy, hallucination, measurement, and all those things. So you can literally extend that same platform onto the RAFT and take advantage of it.
So if we already have a RAG attached to our models and we want to implement this solution, we could do that by bringing in the fine-tuning method.
Absolutely. Absolutely. There's nothing stopping, right? Going back to that, our step 9 in that diagram. Hey, instead of that answer, the question and the context going to this LLM, I can have literally another agent there sitting. Hey, now you make a determination. This one should go to this RAFT. This one should go to this RAFT, whatever that is. You can make that. Those are all more sophistication around how you route your context into a different models.
That's fantastic.
Yeah. Does that
the modularity to be able to plug that in is really fantastic.
Yep. I mean, that's the fascinating and the things I love about this particular one. Even going back to the thing, right, Caleb, I'm pretty sure you're like the whole embedding, even the retrieval mechanism, all those can be segregated by your domain type. You don't need to be a single retrieval tactic for a thing, right? Now, taking that same example of a manufacturing to a medical surgery, now you can have two different pipelines and have the things, right? There are some common pipelines, common components, and there are some unique pipeline components you have within that framework. All right, so that's what so open book, I'm not going to spend a lot of thing, but the important part, right? So very little bit of a math here. I'm not going to go crazy, but I'll try to be simple and easy, right? So in terms of the document, when you're all read it. It's a very well simply written RAFT paper. So I think it's pretty easy to understand, right? So some of the things what I really wanted to talk about is, I mean, this is the thing what they're talking about, the distraction and the things, and we'll speak to it here, right? So that part of that supervised the fine tuning wise, right? So that's what we are doing. As earlier we were talking about, you train, which is the base model with the corpus of world's open source of information. They did it. You ask a question, you get an answer, right? That's what it is, right? That zero shot interface where you just go. It's a few shot, it's a zero shot. You're asking single question, you get an answer. Then what we did with the RAG interface, you have a question, and then what you're doing, which is D for the document. So you're giving this data set, basically the contextual data set, right? You're providing with the question, and then you get the answer. Same model. You didn't do anything, right? This is the same base model you're doing. Whereas the RAFT, what you're doing is actually what's happening is I'm taking all the good stuff. Okay, I am going and generating this trained data set. The training data set, what I am doing, I mean, this is another beauty, right? You can literally go use the GPT-4. So this is why I want to do it, to reduce your cost, right? To optimally keep it. Hey, I want to invest, like if I have this $50,000, I want to go really work with the GPT-4 API or Turbo, whatever it is. And then I just want to use it to generate my training data set, because I cannot take this and deploy to my production because that will be expensive, but I wanted to use it to generate my training data set because I want an accurate training data set. And this is one of the best model to do it. Then absolutely, because you're limiting your expense, you're limiting the things. So you can use your question and documents and then basically get the answer. And one other important part, I know I'm jumping in a little bit ahead for this one. Another important part is part of this same training data set. You can ask the GPT-4, hey, provide me the chain of thought also. So I'm assuming a lot of you are familiar with the chain of thought. Just for the understanding purposes, I'll just go through this here. Okay. This is a question. The chain of thought is really, you can literally generate this through GPT-4. It will give you this very detailed, nice answer. Right. So if this is a satisfied answer for you, you can ask this question, whatever that question is, right? So some family is a part of a hotel company, XYZ, right? And this is the answer. And basically, this is the context they provided, part of the RAG, right? This is the D, the document D, the question and the document D. This is additional instruction they are giving, and then they are going to get the answer, right? And the caught answer, the chain of thought answer. This is an important one, right? The chain of thought thing. This is up to here, the chain of thought. What is the question? The question is, the O'Brien family is part of a hotel company that has held, that has a head office in what city? Right? That was a question. And the context, whatever they provided a bunch of the context. The O'Brien Group is a hotel company with its head office in Delhi, blah, 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 right? They provided a lot more information here, just to confuse and things, etc. Right? And the instruction set is basically, I want the question to be answered with the reasoning, which is the chain of thought I wanted. So how the GPT provides you is, why I'm stressing on this one, because this is the important part of the RAFT training, right? For your data set and the training. So the chain of thought answer it provides, it gives you the reason. So it does all this reasoning, right? It does the reasoning in the beginnings and the end of the quotes and the things. So it understands the step-by-step reasoning by looking at this context, what you are provided. And then finally provided the answer, what it is needed. Right? So it says, therefore, the O'Brien family is a part of a hotel company whose head office is in Delhi. And hence, the answer is this thing. That's the beauty about RAFT, which I'm really liking it, because now this is a very specific domain asked question. Now, even though it's a very general question, they took it and asked for it, but it is like, this is how you're going to develop your domain specific. So you take your document, you create a context, you get the chain of thought information into it, and then you take this stuff, you go train your model, create the RAFT model. The fine tuning we are talking about, the retrieval augmented fine tuning, you're doing using this retrieval augmentation, which is this one, with chain of thought answer, right? So you're telling, hey, model, your existing model, right? I'm giving you this context. This context has, going back to that picture of the RAG circle, I have these blue dots and I have these green dots. The green dots are nothing but, in this case, this. All this is nonsense, right? Honestly speaking, you all know this. This is nonsense for that question. That's a noise. That's a distraction. The core value is in this particular, I mean, if some smart way, if it could identify this is the answer statement, then I can easily give you an answer Delhi, right? But that's not the way it works, right? The semantic search works is, I am close by. Oh, I see all this information in this vector space. I'm going to pull all that, create that as a context. This is a context. All this is distraction, which is, we'll talk about in the algorithm, right? So these are the distraction documents, and these are the good document. This is a golden document, the Oracle doc. Part of the paper, they use this word called Oracle document. Oracle document is nothing but this, right? Oracle document is nothing but this, because that's the answer exists, right? So they're telling the model to understand how we were able to come to that concluded answer. And then how they are telling the model to concluded answer, they're giving the chain of thought answer. This is how it broken down, that as in the model. So you can use GPT-4 or any other good models to go generate this type of training information, and then take a model like Mistral or LM or 2, 7B, right? Any of those models, and then you start training this thing, miracles happens, and we'll see those miracles happened in the part of it, how it did it, right? So coming back to our formula here. Right. So part of that one, the reason I had to bring the chain of thought and the documents, it's very, very important, right? So you have this, the probable proximity, like basically like, the possibility of the data having inside this thing, right? So there is a percentage of possibility that that answer is there in this data set of D to DK. Right? That means each D assume that here, that data set as a chunk. What is chunk? Chunk is your parts of document. You're literally taking a A4 paper and you're chunking them into the multiple, you're cutting them into the multiple places. Just assume that way, right? So you're literally chunking them. And that's what those chunks are. In that chunks, only certain chunks belongs to the proximity of, basically the possibility of that answer being there. Right? For this question, Q. And then basically you get the answer A, whatever that answer A is. Right? That's what that, and everything 1 minus P, basically what this mean is 1 minus P, because as a probability 0 to 1, right? So the 1 minus P, which is basically all the non-possibility of data. What is all non-possibility of data? Okay, I'll take you back here. I'm sorry if I'm changing the screen, but it's important. All non-possibility of data is this. This is a distraction. This is all non-possibility. 1 minus P. Right? That's what this is. So if you have that all that non-possibility of data, I want to give it and I can tell them, hey, my answer is this thing. My chain of thought was this thing. But this is the thing. So you are able to continuously train with the good ones and bad ones, and you can help the model to update on your documents, right? So that's where, like in this case, if it is a D0, D1 is the good documents and D2 to DK is a distraction. So they talk about this Oracle. Oracle is a good document in this document when you're reading. And the distractions are, I don't want to call it as a bad document, but just it's a distraction. It's not relevant to the question what we are asking, right? So depending on that one. So once the model gets understanding with this chain of thought, which is a very, very important part of the training, because they trained it without chain of thought and with the chain of thought. Without the chain of thought, the model did not get tuned well. With the chain of thought, because it was able to understand how it is breaking this good Oracle document versus a distraction, and it was able to form it and able to update the model accordingly with existing corpus of the information what it developed, right? I want to go to this. So hopefully you understood this chain of thought, why it's so critical. I want to go spend time on this one. I think we are getting close to our time. So I'll try to keep it. And then this is what effect of chain of thought. So please read. This is a fantastic, very nicely written paper. I highly encourage everybody to read it. Please. Okay. So this is what they did, right? GPT 3.5 with RAG, right? This is the data set what they have. Sorry. Okay. This is the results what they have for each of these data sets. That closed book, open book example of right? So if you really look at, this is the open book. Why is it open book? Because it's a RAG. Because it's a RAG, you're sending the context of this PubMed, whatever that specific question. The accuracy levels in the GPT 3.5 is at 71% or 41.5, all these numbers are there. So this is GPT, OpenAI with $1 billion who built this, right? That's a beauty. Now, let's come to this one. Llama 2, open source, 7 billion parameters versus, I think this one, you guys correct me, it's 178 billion somewhere, GPT 3.5. So we're talking about 25x, 2500, right? So 25x times bigger than the what Llama 2 7B is. So tiny open source thing. When you did that without, this is a base model. This is our foundational model when we are asking with a zero chart, right? So when we asked, it was able to, because this is open source information, they were able to answer for 56.5. The rest of them, it did poorly, very badly, because it's a base model. You don't have every set of information. So I did pretty bad, matter of fact. Okay. Then second, they did it with RAG. Now they provided context. Oh, there was an improvement. Still, it did very bad with hotpot QA. You can read it. Why is it bad? Because the type of the RAG it is using, right? The data structure, the earlier we were talking about, because you're chunking, retrieval, embedding, and how that structure is, that also matters when you're doing a plain RAG. Okay, so the plain RAG, if you're using, it matters. So that's why it's some of it is not really in a structured elemental data type versus a PDF of a plain text. If it is a plain text PDF, it's a pretty solid, in terms of RAG leveraging and giving you the accuracy level. So it matters how your data structure is, matters into these things. Right. So the hotpot QA did pretty bad, and the Hugging Face data perspective and the rest of them. Right. So you guys see the numbers, how it improved. Then your domain specific fine-tuned one. right? You take the domain specific, you tune the model, and then you start asking the questions. And they did pretty good job. But still, if you really look at GPT 3.5, most of the cases it didn't do, like, still GPT was beating everything, right? So they did that domain specific fine tuning. It really a lot of improvement here. Touch Hub, TensorFlow, Hugging Face. So what did we learn? Fine tuning has a value to it. Absolutely great value. Given, right? Given, still it's a point in time knowledge base. Point in time, right? So that's the challenge. Fine tuning is powerful. Fine tuning has a value, but it's a point in time. So it's not solving all the problems what enterprise really need, right? What did we do with the fine tuning with the RAG? What is the difference between this and RAFT? Anybody want to chime in? Anybody want to share? What's the difference between this versus RAFT? Okay, I'll take it, right? So the difference, fundamental difference is the training mechanism. The fundamental model is, so the domain specific foundation model, what we are saying, we didn't train it in the retrieval augmented way. We trained it with the knowledge what we have about the domain. We given the information, we trained it, and then we augmented it using the RAG technique as one of the foundational model for the domains. But in case of RAFT, we are training with the RAG context, meaning the PDF chunks, and we are giving the context chain of thought. That's a foundational fundamental difference between the DSF plus RAG versus the RAFT. Right, so it's a key difference just to be make sure you're following into it. That's the reason. I mean, if you really look at it, hey, I don't want to go spend time do the RAG based tuning. Yeah, it depends what type of thing you want to do it. So DSF plus RAG also did a very good job. Actually, it met almost with the GPT-3 thing, but hotpot QA still it was not there, right? Versus Hugging Face and all these things it didn't. But whereas the RAFT, the numbers speak. Bottom line. Yeah, sorry, go ahead.
Yeah, and it's worth mentioning that GPT 3.5 Turbo is larger than Llama 2 to 7 billion. Okay. And so that's
Very
less than
large.
it's a substantial gain in efficiency to go that route.
Okay.
And well worth noting. Anyway, go ahead.
I think very, very important point. I might have said it very lightly, part of the conversation. It is 25 times bigger than the Llama 2.7 billion. It's, I think, 175 billion or 78 billion, roughly around, if I remember correctly, the GPT 3.5 versus Llama 2. Because it's a smaller model, it can run on a smaller GPU with a smaller memory, a lot of other advantages, right? So that's what. So how do we really take advantage of these things? Is it RAFT solves every problem? No. That's where the beauty. RAFT, one wing of the things in the business. That's where you really have to see it. What fits your right model, but definitely RAFT is one of the solutions for a lot of the specific problems. And then other RAG adapted models you can adopt to solve the different one, but RAFT definitely did a great job specific to this setting of the data set. With that, I think that's what I really wanted to share and why you should be shown interest into the RAFT and especially leveraging it and experiment with the LoRa for the fine tuning and try to experiment and let us know. And anything I can share on anybody who does the thing, please let us know. Yes, Caleb, please.
Yeah, so I have a couple of questions for you. One is, where do you see RAFT's future going as these models, as more models are born, as this technology evolves? Obviously we're not going to be using the same AI, next year that we're using today. So where do you see RAFT fitting into those future models?
Right. So actually, this also aligns with your previous question where you're mentioning, hey, if my documents change, how often I have to do the fine tuning, right? For the RAFT fine tuning perspective, it's a similar, right? So as the new model, because we are right now doing the Llama 2.7 billion. Now, let's say if I do this on the Llama 2.30 billion, is the performance like dramatically, or is the performance is going to be at the same level? What is that difference it's really providing? So it's an experimentation we have to do specific to the RAFT. I think the methodology will be there similar to the RAG, right? So methodology will be there, but the more I see, I think the where it's going to be changing is optimizing your retrieval mechanism. labeling a lot more information into the vector database with the elements, with the documents, getting much more smarter with the semantic search, retrieval perspective, right? Those, I think the
Right.
left side of the world will be a lot more matured as the RAG and RAFT is getting. And RAFT is not for everybody because you need to know fine tuning, maintenance, and you have very nice pipeline in terms of those things and maintaining the training data set. So it's a definitely a bit of a complexity involved. So depending on the things, because it's versus RAG. RAG is extremely simple compared to RAFT.
Awesome, thank you. And then my last question, and probably one to help you wrap up, is what initial steps would you say if we're interested in utilizing this technology, if we want to start messing around with it and maybe our own fine-tuned models, where would you say we get started? Where would you point us to?
Yeah, I mean, so the point out perspective, I think the best example is the first start with reading this paper, right? Absolutely, I would highly
Do our
encourage.
homework first. Got
Yeah,
it.
please do this. And then you also have a great article in the UC Berkeley, the Gorilla, the team actually who really worked on this RAFT, who wrote this paper. So read, they have a fantastic document there and sample documents to experiment with it. And the third one, Microsoft actually has a great RAFT AI fine-tuning perspective of the model. So you can go to the Microsoft, and if you search for the Microsoft RAFT, and they give you a free access, you can actually use your own native. There, the beauty is you don't need to be so familiar with Allura or other techniques to fine-tune. You can use the studio to fine-tune and
Oh,
experiment.
fantastic.
Example like other gentleman who was mentioning, right, when they had 3 similar documents, how the result set is, you do it without RAG, just like how you have it here, right? So do your own experiment with your own 3 PDFs, right? Start with this thing, look at your accuracy and relative information you're getting and see how it is performing for your own specific data. And that should really get you hands-on and also show you the value, whether it's something you should pursue or not.
Great.
Fantastic answer. Thank you.
Absolutely. All right. We have a few more minutes left. If anyone has any further questions, I see that a really nice crowd today, some new faces, and this is an evolving art. I mean, it's a science, but it's not set in stone yet and probably never will be. So as things evolve, new techniques are going to come up, but staying modular is just so important. And, along the way, I've learned a lot from you, Caleb, with things that you've shown us over the course of the last 4 months privately. And it's phenomenal to see what you can do. But when we brush up against the limits of these systems, it's painful. And it can be bad in money ways. It can really hurt
Right.
an image. It can misguide a user or a customer. It's something that we've seen change. I mean, during the course of things that we've shown off in these presentations and labs and building bots from scratch, or hey, let's make a MyGPT or do something on Poe. We'll find that things work until they don't. And because something changes somewhere, whatever you may have built for RAG isn't working because, well, you're getting A/B tested over at OpenAI. And for other reasons, depending, you might experience that because of new laws. And they've done this with, I had a book that I bought that was an ebook, and I loaded it into a bot so that I could learn from it and ask questions to it. But when I asked it to quote anything from it, guess what? It says we can no longer provide copywritten information to you. I paid for the book. I put it in there. I could read it, but I just wanted it to do that. I can get a review on the book, at OpenAI, but that bot no longer works like it used to. So several weeks ago, I had something that was a great presentation, no longer functions. And so, staying modular and having a better, a well-formed approach to managing your data before you even get it to the table for all of this is key. And again, I've never seen anyone put together as much as you have, Caleb, with your data and a lot of what you've done. And then along the way, Suman, you've really delivered a lot of value to us over all these presentations. And I know we're going to keep doing these as things continue. But this is great. And I put the link to your the PDF that we were referring to in the chat for everyone. You know, we'll get back to this in a few weeks probably and check in and see where things are at. But until then, I hope everyone learned a lot. This is not easy work. It's exciting that we can actually do something to make an impact. But we're all in this together, and we all have to, you know, learn as we go and evolve our techniques. And then Suman, what you got there?
Yeah, I just want to say thank you, Daniel. I mean, for setting this up, and it's exciting to share and share the knowledge across, right? Like I think you conducted so many other sessions too, and it's fascinating to hear, especially from some of our cohorts. And now we are expanding this into the more audience. So this is fantastic.